quiz on Friday. So I may want to take a quick look at one of those before I move on. And all the inequalities. Now, Mr. Park sent out the answers to you guys. And I'm asking for next time he sends out the answer to the document, I have it in class here. We're going to try to also show the work required to get there, not just the answers, okay? So that completion of the square worries me. So I'm going to actually start out with that today for just a quick review of that completion of the square process. I know some of my students may have seen completion of the square before. They may have a little different technique than I do, which is fine. But that's one technique or process we need to look at first. And then I'll look at all these inequalities. Did anyone, now I sense I had some good students already, lots of good students. Did anyone attempt all of this? Did anyone actually say, Professor, I'm gonna sit down and I'm gonna try all these inequalities that were on the back here of the page? Did anyone try that? Because I actually did not get a chance to really get into it. So you may have thought, well, I better wait on the professor before I do that. Okay, so that's where my job will be today, to start with that. Guys, any quick questions before I jump in and do what I gotta do? Like I said, please keep the energy going. If we can just keep that energy going for the next weeks, we should do okay. Now, Friday, the first quiz, and I know when I say quiz, not exam, quiz, it's only 10 points. But right now, you gotta be very careful though. I'll let you know further along in the week here how much of the material will be covered on that quiz and what you're responsible for. Definitely, you know you're going to solve the equation for me. And more than likely, you'll have to solve at least one by completion of the square. Okay, so you know there's something about solving equations on that first quiz. And of course, inequalities are coming up, and then a few more things tomorrow, and Thursday, a few more things. We'll have a nice little quiz, probably about 5 problems, 2 points each, about 10 points. It will be 10 points, okay? Any quick questions, guys? Anything at all? I've been bragging on you already. I don't know whether you guys saw one professor walked in after you guys left, and he's teaching also this class, Math 2, but it's called Math 2C. He's teaching it with a co-rec, where he and the students meet for a little bit more time than we do. Here we just have Math 2, he's doing Math 2C, a co-rec class. And so he's coming in and says, oh, Professor, I need to move some of my students to your class. I don't have room. When all students are here, all the seats are taken, so I don't have room. I would like to have some of his students, but no, not at this point. Okay, so we're satisfied right where we are. Guys, if there are no questions, here's what I want to do. Like I said, Mr. Park sent out the answers to the handout. And I'm going to look at number 2 there, and I think he gave us the answer, part 2, number 2 from that handout. Oh, does everyone have the handout from yesterday? We do, don't we? Hi. Guys, we sent out the answer, and it looked like this. Let me see what's going to happen here. So part 1, let's start this with part 1, and solve. Yes, we're going to do this by completion of the square, and it looked like this. 2x squared, 8x, subtract 7, is equal to 0. Now, you will see 1 by completion of the square for sure on the quiz Friday. Also on the exam the following Friday. What should I be on the alert about first if I intend to use this process called completion of the square? Does anyone recall? Is there a requirement that I need to meet before I start the completion of the square? Anyone recall? Can I just jump into it and start something called completion of the square, or is there a requirement needed? Yes? That leading coefficient, in my case it's a 2, it's going to be a 1. So completion of the square will not work unless that leading coefficient is a 1. So my job first is now to, I'm gonna do it like this, as she's just suggested to me, divide everything by 2, and rewrite the equation, no mistake here, as that. Now my leading coefficient, now let you see the back if I give you a weight. Okay. So guys, rewritten, leading coefficients of 1, that means now I can start this process. Now the way I did my completion of the square with you, I first, put this to step 1, we isolated the x terms. In other words, I just moved the 7/2 over. And then my job now is to come up with and try to complete the square. In other words, I want a square involved here. You say, Professor, I see an x squared. No, I mean a quantity being squared. So that means something is missing for this left-hand side. I'll put that missing part with the blank there. Of course, if I add it on the left, I've got to add it on the right to keep this balanced. So I'm trying to come up with something that will have a nice, complete square on the left-hand side. Now, does anyone see a number that I can add? I got to add both sides to make that happen in this case. Yes?
Was it 4?
It is 4. Now, if you don't see it right quickly, we came up with what, a little technique, I think. Students were asked me to take 1/2 of this coefficient, middle coefficient, coefficient of the x, take half of that, which is -2, then squared. Correct, it is 4. Now, better yet, if that's correct, the left-hand side now should be, here's the whole purpose, it should be a nice, perfect square. That's why they call it completion of the square, and there it is. That's the way the left-hand side now looks. The other side may require a little bit of work here, arithmetic, common denominator of 2. Guys, if I put those two together with a common denominator of 2, I'm looking at 7/2 plus, I guess, 8/2. Is that true? Is that 15/2? That's mere arithmetic. And that's step 2, and I now have my square need. Now, at this point, we should all know that if I intend to complete this and finish it up and get an answer, what should I do next? At this point, step 2 looks good. What should I do with step 2 to now go further and actually find the answers? What is it? Yes?
We have to do square root.
The square root, that's the whole purpose. If I go back and say, now I need to do this. And thank goodness that left-hand side is nice. We made it nice. It's merely x subtract 2. How many answers should I end up with for a quadratic? Always 2, so that's why we put plus minus. Now I realize I got some strange numbers here, 15/2, 15/2 for that square root. I could, here goes, watch carefully. I could separate them, if that would help. Write this as radical 15 square root 15 over square root 2. That's valid. I think I had one yesterday that we did the same thing to, and one of these I think was a nice perfect square root, wasn't it? This one, neither one are. Now, does anyone recall what might have to be done, maybe from a previous class? Neither one are perfect square roots, but there's something that you were told way back somewhere about radicals. What should I do? What should we worry about here? Yes? You cannot leave a radical in the denominator. It's called rationalizing. You've got to change an irrational number, which is that square root, into a rational number. So I cannot leave this here. You say, Professor, I cannot leave a radical in the denominator. You cannot rationalize the denominator. And that, in this case, merely multiply numerator and denominator by that. Now please tell me, will this now give me just 2? Actually, radical 4, or just 2, which I want. No radical in there. So let me stick with that right-hand side. Write this as plus minus. Strange answer here. Plus minus on top, radical 30. As we said before, this is radical 4, or just plain 2 in my denominator, which I want. I still have this mess over here. I'm so glad I worked this out, because Mr. Farkas, he just gives the answer, but look at all the work required here. Now I gotta solve for x, guys. Make sure you understand what we're doing up to this point. To solve for x, I need to add 2, in other words, move that over, and add this to be 2 plus minus radical 30 over 2. Now, if I scored a paper and I saw that answer right there, I'd be happy. I don't think I'd give you full credit, but I would be very, 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 very happy. The reason I would not be completely happy is I should do something with these two. It's true, this is the answer, but it's awkward. Does anyone know what to do with those two terms? That might make the answer look a little better. Yes?
Have a common denominator.
The common denominator. That's like 2 over 1, and what common denominator do we have in mind here? A 2. So I want everything written over 2, which makes the answer look much better. So wait, Professor, the second term is over 2. That's good. But my first term is not. So let's multiply this by 2 to make that 2 show up where I want it. So I multiply top and bottom by 2. Now, will I finally end up with 4 plus minus, put it in red here, plus minus radical 30 all over the common denominator of 2. Is that true? Strange answer. By the way, is this the answer Mr. Park sent out to us? Yeah, Mr. Park is to the point where he can almost look at this in the black here, the original, and all of a sudden he has that. Just does it like that. Okay, took a little time there. Now the sad thing is, on this one, that radical 30 will not simplify. Too bad it wasn't an 8. Can anyone tell me if it were a radical 8, we would not be finished? What would radical 8 do for me that radical 30 is not doing? Suppose this had been radical 8, square root 8. Can anyone tell me what would happen? Yes, go ahead.
It has something to do with the fact that it's a 4 plus or minus radical 8, so you can probably simplify it a little.
Okay, well, at radical 8.
Also radical 8 over 2.
Okay, let's just zoom in on just radical 8. Let's say it was radical 8, not radical 30. Let's not be concerned about these right now. Just radical 8 rather than a radical 30, just out of curiosity. Yes?
You can pull the 4 out of it.
Look at this. If it had been radical 8, which it wasn't, but who knows, it may happen on the quiz. He's telling me, hold on, Professor, this won't break down. So simplify, 4 times 2. Or better yet, radical 4, of course, is 2, so it's 2 radical 2, and that would go there. If it had happened, if it were a radical 8. Mine wasn't, but I wanted to point it out before I leave it. Now let's assume it was. We're finished with the problem here, guys. The answer is this. But let's say it was, and you would have 4 plus minus, with his help, 2 radical 2, if that had been an 8, and we'll point out, still over 2. Just in case. Now what could you do at this point with that to make it even look better if all this should have happened? Yes?
Well, can't you cancel out the 2 outside of the radical and then simplify the 4 down to
Look at this, look at this. I hear what you're saying. See all those numbers? Can they be reduced down? Can I divide all those by 2?
Yeah.
If I do, look what a nice answer comes out. 4 divided by 2, of course, is 2 reduced down. Plus, minus, 2 divided by 2, that's 1. 1 radical 2. All over, understood to be a 1, which doesn't look right. Look at this. See how the answer looks like that? Rather than what we got, and this what is the correct answer for what the problem might work. But if this should have happened, I just want you to be aware of it. Then that would be the answer. That would have been 8 rather than 30. Okay? Make sense? Just get you ready for that quiz. Okay. Now, of course, we're finished with this. Done. But I wanted to do that. Guys, that was completion of the square. Now, part 2. Finally. Yes. We can get into this. Inequalities. Let me point out, and I think most of my students, if not all my students, probably realize, inequalities now we're dealing with, guys, this. symbols. And I guarantee you, every student at this level of math probably realizes, Professor, if I see this symbol right here, it means greater than. If I see this symbol, the way it looks, less than. This one with the, what, little mark underneath it means what? Greater than or equal to. And then less than or equal to. And those are called inequalities. And now they want us to solve some inequalities and get a solution. I pointed out right at the end of class there, the inequality solutions may not be just one or two answers. This thing has two answers here. This is an equation. It may have an infinite number of answers. So I may have to use interval notation. Now I'm going to start out before I jump into a problem. Can anyone tell me what, if this should have would happen? X is greater than 5, put a semicolon. What would that look like to show someone in the so-called interval notation that my solution is everything bigger than 5? What would that look like if I use something called interval notation? We'll start out with 5, and since it goes forever, there's infinity. That's interval notation. That says X is greater than 5. We prefer in mathematics, especially higher mathematics, to do this. To say X is greater than 5. Number 2, if I should end up with, say, X is less than or equal to a -3, I'd like to express it with this so-called interval notation, with the infinity maybe coming up somewhere, maybe. Guys, X is less than or equal to a -3, be careful. It says everything to the left of -3. So it's a negative infinity, up to -3. Now, can anyone tell me, remind yourselves, what should I do here at the end to show at that end point -3? Is -3 supposed to be included? The way it's written, I see a little equals mark under there. It shows it's supposed to be included. We use in mathematics a bracket. So that right here says everything less than or equal to a -3. Next one, number 3, let's try this. See if I work this, I do. X is greater than or equal to 0. Everything to the right of 0, guys. Let's write this as with a bracket, 0 through infinity. Just a little recap on a few of these that you may have to write in interval notation. Now, does that sort of recall, you recall some of this now from maybe a previous experience, interval notation? Now, on your handout, let's see if I'm ready. Hope I am. Sure enough, if I jump to part 3 on your handout, it says now to solve, oh, this part 3 here, solve these inequalities. And we're going to express the solution using interval notation. Now, notice the first couple are a little strange. I would prefer to go back to them here. I'm going to go try something else first and come back to them. Guys, I'm going to try it first for my first one. Maybe this. And in fact, it may not even be on the handout. I want to do this. 4x plus 6 is less than -2. I'm going to go way back. Middle school. You guys remember middle school? Did you have fun in middle school? I hope you did. Those days are gone. Elementary school, you remember elementary? Yeah, do they still give you guys in elementary a little break and they have cookies and smile and the teacher's smiling, you're smiling, parents are smiling? Is that still going on? Of course it is. Those days are gone. Those days are gone. Now, if I'm going to solve this, we'll solve it much like an equation. Subtract 6. Let's jump right into it so you guys know what's going on here. I get a -8. Divide by 4. Just a little simple one here to start out with. You know this from pencil. X is less than, looks like a -2. Now, if I say now express that answer in this type of notation, everything less than -2, be careful. Open, parenthesis, negative infinity, up to a -2, open. Do we agree with that? That's where the interval notation we look. That's what we're talking about in the next section of this handout. Part B, before I jump directly into the handout, I might be ready for it though, almost. Oh, here we go, almost. Next one looks like this, 2x squared less than x plus 3. I said, hold on, Professor, that looks something like in quadratic that we were doing yesterday. So in my mind, that's a quadratic formula. Did you want me to complete the square, Professor? It's a quadratic. Did you want me to factor? Those little techniques we talked about yesterday. But first, let's put this in good form. That means I need to rewrite. Now watch carefully. Move things over. I need to rewrite it in, I'm going to call it standard form. I need to get that 0 on one side. Now this takes into consideration there's a connection here. I try to make my lessons always connect. The lesson from yesterday was, yes, I can solve this. Now it's up to you. Did you want to complete the square? We'll go on the side here and solve that quadratic by completion of the square like I did the other problem? Or did you want to try to factor it? Or did you want to use the quadratic formula? And then you come back and a little bit more to be done. Guys, I think, to save me a little time, I think this one will factor. If your factoring skills are a little weak, take this quadratic over on the side here and use quadratic formula. Negative b plus minus business we talked about yesterday. Now you guys who are good at factoring, does it factor? Which would save me a lot of time if it does. Let's try to factor it. I see a 2x, I think, and an x for 2x squared. Oh boy, I gotta be careful myself. Is it for the negative 3 on the end, negative 3 plus 1 for those last terms? Yes or no? Well, gotta be careful. Is that factored correctly or not? Oh, our factoring skills are gone. 2 TAs back there want to start bringing cookies in. Oh my goodness. Is that the correct factor? Now how do I check to make sure? Well, definitely. From yesterday, that product there is what, 2x? Is that 2x? If I multiply these two inside, is that negative 3x? So if I put a negative 3x and a positive 2x combined like terms, do I end up with negative 1x in the middle there? Is that true, guys? So it looks like it does factor. If your factoring skills are weak, and you say, Professor, I don't know how to factor very well, then you could go over to the side, like I said, and use quadratic formula. By the way, now it's factored. Now, you have not seen me do one of these quadratic inequalities. Yesterday we would have stopped here and set each one equal to 0 and solve. I think you're going to get like a 3/2 here on this one. And I think the other answer coming up is a negative 1. That's true from yesterday. Now this one says not equals. They want, all the numbers will make this in the red less than 0. What can I replace x by in the red? Do my business there, multiply the results out, and you end up with a number less than 0, which is negative. Now, I don't know that here's going at random. Randomly, I'm just throw out a number and see if it works. I'm going to try negative. Maybe part of the solution is the number negative 4. If I replace x by a negative 4, guys, this is negative 8. I'll just randomly try a number. Negative 8 subtract 3, I think it's a negative 11. I'm keeping track of my numbers here. Negative 11. I'm trying here 4, a negative 4, I think I said negative 4. Negative 4 here is negative 4 plus 1, that's a negative 3. Do I have a negative 11 times a negative 3? Is that positive 33? Is that going to satisfy this inequality? No. They want you to find the numbers that will, if there are any. Does anyone just at random think there is one? Give me one that just at random you think would work. My number didn't work. I tried negative 4. Does anyone think they know a number that when you replace it and do your business there, it satisfies the inequality? Just a random. Give me a number. I'll try it. I tried negative 4, it didn't work. Maybe there are none. Will 0 work? 2 times 0, that's 0. Subtract 3, that gives me for the first quantity, negative 3. 0 plus 1, that's a positive 1. So I go what? Negative 3 times 1? which is -3, will -3 satisfy this inequality? Is -3 less than 0?
Yes.
Yes. Now, well, you know, we can't sit here and just randomly select numbers. He wants to find all of them. And I think you get a sense there's an infinite number of them that will work. Now, what am I going to do to find them? You know what's it there, that would be your exam. You take the entire hour, or your quiz on Friday, if you're just randomly trying to find all of them. Anyone have an idea? And the little technique I'm gonna show you, the way I'm gonna do it, may be a little different than what you've seen before, but I like it because it ties in with what we did yesterday. Now, from yesterday, I would go ahead and do this. That's wait, Professor, you were doing this yesterday. You were saying each one of these factors equal to 0, and you solved quickly and got answers. Is that true? Now, if I were in class yesterday, this was an equals mark, and you would be finished. This was not an equals mark, it's an inequality. Now, we'll tie in this though with what I want to do here. I'm going to take those two numbers, look at this guys, and place them on a number line. 3 halves and a -1. So we'll place -1 here, 3 halves, which is 1 1/2 there. I'm actually showing my little sketch there. That's from yesterday. Maybe I do a little bit more. Now notice it says less than, not less than or equal to. So that means those two numbers I got from yesterday, just placed on that number line, are not to be included. I don't see an equals mark there. So they are open like that. Just to show they're not to be included. Now, I'd like to know, now since I have the number lines broken up in 3 intervals, is it all these numbers out here going to work? Satisfy this back here like I was randomly selecting numbers? Or is it all these numbers caught between that will satisfy this inequality? Or is it all the numbers out to the right of 3 halves are satisfied? You need now to test a number, just one single number will do it. You need to test a number in each one of those intervals. Now watch what happened here. At your choice. Out to the left of -1, I don't care whether you try -1,000. I'm gonna try -10 myself. But you need to show me your test number. So I'm gonna try -10 out here in this interval. In between, I think 0 would be nice to test. There's other possibilities. So I'm gonna try 0. Out to the right of 1 1/2, I'm gonna try 100. It's up to you as to what you want to try here. Now I gotta see your test numbers. Then I said, Professor, what are you gonna do? I'm gonna test them. Watch what I'm gonna do here. Going back to the red. I'm gonna replace by, looks like it's -10 I'm trying here. You're saying, Professor, you're actually gonna replace these x's by -10 and get numbers and so forth and so on. I do not need to do all that. Watch what's gonna happen. If I should replace x by -10, I get -20 minus 3. That's a -23. All I'm concerned about is the sign in this process. So the sign is negative for the 2x minus 3. In the x plus 1, if I replace that -10 also in this second factor, -10 plus 1 is what? -9, another negative. I'm just concerned with the sign. I don't really need the numbers. Guys, what is a negative times a negative from way back? Is that a positive?
Yes.
That says if you test here, you've discovered those numbers out there will give you a positive. We're looking back though, we're looking for a less than, we're looking for a negative. So I tested, and to the left there's not working. Maybe in between, I've seen some of these where nothing works. In between, I chose to use 0. That falls in between these two, in this interval. Guys, if I try 0, 2 times 0 is 0, of course. 0 subtract 3 gives me a negative. 0 plus 1 in the other factor gives me a positive. Positive 1. A negative times a positive, we all know is this. Please tell me, is that what I was looking for to satisfy this inequality? So from that one test, I discovered an interval where it said all this works. And all you need to do is just test one number. Out to the right may work. I haven't tested yet. You say, oh, Professor, why did you choose 100? Well, it's up to you as to what test number it is. If I put 100 in here, that's 200 subtract 3. I know that's going to be a positive answer. And 100 plus 1, you know that's 101. That's another positive. And a positive times a positive is going to give me a positive. Now, what's my answer? What worked? Well, the answer to this, look at this. Here's the original. We did it through this process. The answer here is an interval notation, the interval from -1 up to 3 halves, written like that. Now, you guys who have seen maybe something like this before, especially when you reach Math 7 to use this technique, also Math 7 for some problems, they call this sign analysis. Sign analysis. You're doing an analysis using the signs. You try to come up with the solution for an inequality. Woo, is it a lengthy process? It is. It's a lengthy process. Guys, any concerns about what I'm doing here? So if I say use sign analysis on the quiz on Friday, you got to show me all this work. Okay, I'm trying another one here. Letter C. Let's see if I have another nice one from the handouts where I formed one myself here. Oh, beautiful. 3x is greater than 2x squared. It's a quadratic inequality. Guys, to solve it, I know my students will probably try a different variety of procedures here. Oh, here goes. Someone give me an idea. What would you do first here? Just get a start. Any ideas? Go ahead.
Move the 3x over.
You know what? Most students say, Professor, move that by subtracting the 3x over. I like that. Absolutely. Now keep in mind, this is a quadratic, and he has now a quadratic. Now with that quadratic, I can either try to use a square, quadratic formula, or factor. Guys, I think here, will 2x squared subtract 3x that we have, will that factor? Is there a common factor that I could take out of that expression? A common factor of what? X? Leaving 2x subtract 3. That is factor. Now you said, Professor, you don't have the solution yet. So what are you going to do? I'm going to go back to this again. I'm going to use sign analysis again. Start testing and find which interval works. By the way, this is written a little awkward. Students can leave it like that if you wish. I would prefer just to turn it around, make it look more presentable, and make it look more like this. It's entirely up to you though. Guys, these two statements are saying the same thing. This and this are saying the same thing, just turn it around. I would prefer it like this, it's up to you. Now to get my critical numbers, I'm gonna start calling them critical numbers. Let's set x equals 0. And of course, if I solve this one, if I'm patient, you're going to end up with 3 halves. I think I had 3 halves in that last one somewhere, I did. So I got a 0 and a 3 halves. Do I, guys? I look at my critical numbers. Go to a number line. We'll use sign analysis. I find this sign analysis would be a powerful method to solve these. I got 0 and I have 3 halves. Not to be included. Open it. And you start your testing. Same process, you start your testing. To the left of 0, it's entirely up to you. We'll try -2. In between, we'll try 1. Out to the right, we'll try maybe a 5. Those numbers are selected by you. Now, let's do the signs. I'm going back to my blocked off version here. Replacing x by -2. If I replace the x out front by -2, of course, it's negative. Inside here, replace x by -2. I see it's a -4 subtract 3. That's a -7. So I got two negatives going on. And negative times a negative is a positive. And just so happens that when I'm working here, I'm looking for something less than 0, which means negative. So that part is not working, is it? Is that true, guys? Is it not working? In between, I'm trying 1. If I put a 1 here, of course, positive here. 2 times 1 subtract 3 is negative. 2 times 1, 2 subtract 3 is -1. I got positive times a negative, which gives me a negative, which I'm looking for. So I'm going to go ahead and shade this in and say, oh, I found something that works. This was looking too much like this one we just finished up. 5. Put a 5 here for the x, of course, is positive. Second factor, 2 times 5 subtract 3, I think it's a positive 7. And I know that's going to be a positive, which I do not want for this particular problem. Answer, put right here next to it in integral notation, 0 up to 3/2. So those numbers will satisfy the inequality. Oh my goodness, I've been in so many classes myself where I sit there and I enjoyed math so much in grad school, especially grad school. My professors were great. I walked out of class, I just loved my professors. I could just listen to them, watch them, and say, oh, it's like magic. They're just doing all this great stuff, and I'm just sitting there in awe. And they said, Ramsey, you have a quiz on Friday. I know, I'm happy. I love this class. Professor, you are the greatest. Ramsey, you have a quiz on Friday. I know. I don't want to have a quiz on Friday. And all of a sudden, we have a quiz. And Ramsey doesn't do too well. My love started disappearing. I thought, wow, I like this professor. I like this class. I started making some sense of it. And darn it, on my first quiz, I didn't do well. What's wrong? What's wrong? What am I doing? That means Ramsey was not practicing enough. I was leaning more on what he was doing, or she was doing. My strongest math professors in grad school were women. They were the strongest. Men were more interested in the research, writing books. Now the women professors were the strongest professors. I enjoyed the classes. But boy, I was leaning more on what they were doing. I do some things on my own. Okay, letter D. All this looks pretty cute right now. Making some sense here, especially that sign analysis. Now though, I did have a variety of problems here. Guys, I know I got this going on. Here goes. I want to look at letter C first and get some input from you. This one's a little different. It looks like this one's less than or equal to. Now I need some input from you. A little different than what I was doing here. But I can still use this process called sign analysis if I'm clever. Does anyone see anything at all that could be done to get a start? Yes, go ahead.
The -6 and -9 have a common factor of 3. Can you attempt to move on?
I see that. Something else first though. Take a close look. Even before I jump into if I want to use sign analysis a little bit later, even before I start this sign analysis business, if I want to use it. Something else, yes. 3 and a -3, you see a 3 and a -3. Beautiful. He says, Professor, I see right now 3 and a -3 are going to be my critical numbers if I want to use sign analysis. Where do you get 3 and -3? He says, Professor, if you want to use sign analysis on this, like you were doing here, your critical numbers are going to be 3 and -3. Where do you get that? Where did you get that? Right here?
Yeah.
And you're saying replace x by 3, you'll get a 0 up there. You replace x by -3 and do the business up there, you get 0 again. Many students say, also, Professor, does that not factor into, it's called difference of squares? Does that not factor into this? Is that the factoring done? Also, that's to show you it's 3 and -3. Let me do that then. He's already started me out. He says, Professor, you will use sign analysis? Here we go. Let's go to the number line and place those two numbers. Nice. That's my critical numbers. Now notice in the last two cases, my critical numbers were open to show they're not to be included in the answer. Should I include these two? Am I finally to a point where I should include or show some way that these two are to be included? And what makes a difference here? Equals. That means this now can be, look at this guy's not open but darkened in. And here, darkened in. They are to be included in the answer. And we are going to, here we go, sign analysis. Guys, out to the left of -3, it's entirely up to you. I'm going to try -6. In between, I guess I'm going to try 0. Out to the right, I'm going to try 10. Right of 3. Let's see what happens. Be careful. Try -6. I'm going to use the red. I think the red looks better. Put a -6 in there. -6 subtract 3 is a -9. That's a negative altogether. -6 plus 3, that's a -3, another negative. And of course, that's over -6, which is, of course, a negative. Anyone tell me what is that altogether? From middle school, is that a positive on top, negative times negative? Because a positive over a negative, which turns into what? A negative. Does this symbol right here indicate, that's what I'm looking for? Less than 0 says I'm looking for a negative. Well, we found a negative result. So that means all this immediately to the left of -3, including, is to be included. Like I said, I've seen sometimes the entire number line work. I don't think it's going to do it here, but we're going to test. Now I'm testing 0. Let's take 0 back. 0 subtract 3 in the red. Of course, it gives me a negative. -3. 0 plus 3 gives me a positive. And of course, my denominator was set at -6. That's a negative. What is that altogether? Is that a negative over a negative? Which turns into what? Positive? And that's not what I wanted. I'm looking for something less than 0, so I cannot use in between. Out to the right of 3, who knows, may work. I'm trying to 10. 10 subtract 3 is positive. 10 plus 3 is positive. And of course, in the denominator was set at -6. I have that. What is that result there altogether? Is that a negative? So therefore, I have found another part here that works. And there's the answer. Uses sign analysis. Now, if they say, do I express this in interval notation? You gotta be careful. Anyone tell me, bring it down here. What does this look like? Which doesn't work. Everything to the left of -3, including -3. What does that look like in interval notation? Any idea? Go for it.
I think it's -infinity to -3, but with a bracket.
Beautiful.
And then another bracket, 3 to infinity.
Now, when you say there's, Professor, there's another answer, another part of the answer. We usually in math show this symbol here called union, it's like a U, to indicate, don't stop there, there's another part. And the other part she's telling me is bracket 3 goes forever through infinity. And those infinities are always with parentheses. And there's the answer. Now, if you understand the sign analysis, and I'm going to do a couple more here, you can do anything in Math 7 that they throw at you. Just draw a number line, place your numbers, and test. Number line, put your numbers on there and test. Cannot, I don't think, cannot go wrong. Got any concerns about this one? Okay, letter E. I may have to stop here and let you practice something here shortly. Letter E, when I created this worksheet, I did this. Oh boy, did I. Oh my goodness. Okay. Before I jump into, I'm almost at the end of this. Can anyone in this class have an idea of another way to approach, especially that last problem you just did, as you first glanced at it? I love sound analysis on all problems that I can use it. Did anyone have an idea of what on earth in the original black problem there could I have done that made some sense the way it looks, that may have helped me out with another approach? Anyone see it? And that's the trouble with math. Sometimes you just look at it and you say, you don't see what is there in front of you. You're trying to make something difficult. There's something there at the original that may have helped us. We have the answer. I'm just wondering if there's something else. Guys, look at this. Sometimes we overlook things. We all overlook things. Look at that. You want that left-hand side to turn out to be less than 0, or it could be equal to 0. Less than 0, and less than 0 means you want it to be negative. Is part of that blocked off left-hand side already negative? Is the denominator negative right now? What would that force the top to be so the entire expression is, as a 1, negative? The bottom part's negative right now. So how about that top part, which is this? What would that have to be? Positive. So x squared subtract 9, the numerator would have to be positive over that given negative, and a positive over a negative gives me what? A negative of 1. So I've had students do this. I said, wait, professor, you could solve this problem by just considering the top has to be this. It has to be positive. And then gone through factors, use your sign analysis, and gone through and gotten the answer again. Just by mere observation. But guys, we did it fully here, right here. I got letter E. That's what I was going to next. Slow down and see what you guys can do for me here. Here we go. I don't see this one on the handout. We'll make something simple first. It's not laying out. X squared subtract 6x is greater than negative 9. This is another quadratic. Let's put it in standard form. I call it standard form. X squared subtract 6x plus 9 is greater than 0. No problem. Then I think you're taking a close look at it. I think factors. Does anyone see what this factors into? X squared subtract 6x plus 9 factors into something nice. What does it factor into? X subtract 3 times what? X subtract 3. Are you kidding? I had to point this out. Or better yet, since it does factor into that, I think you guys would agree that factoring is that true. At this point, even better, it looks like this. Now they want to know, what can I replace x by to satisfy that inequality? Oh my goodness, I'm standing here just thinking, no matter what you replace x by, I don't care what number you put in here. Then subtract 3, but you're going to square it afterwards. What happens if you square a number? Does it always come up to be, what? Either 0 or positive? Does this mean that's what I'm looking for? I'm looking for a positive? So what do you think right now, without going through your sign analysis, that's just by mere observation right here, what do you think the solution would be? What x's would satisfy this? What may I replace x by? Yes?
Any number except 3.
Thank you. Any number but 3. Why not 3?
3 minus 3 equals 0.
Right, exactly. You put a 3 in that 3, subtract 3 gives you a 0. 0 squared is 0. I don't see an equals here. It didn't say let it be equal to 0. Every other number would work though. Now, without me going through the full sign analysis, can anyone tell me? I like that. You're saying, Professor, you cannot let x be 3. Can you tell me what in interval notation then would the solution look like? Where you're actually saying everything will work, Professor, but 3. Does anyone have an idea what that would look like in interval notation? Go for it.
I would guess it would be negative infinity 3 without the bracket, like it's just a parentheses.
Love it.
And
Tell
then
me
you
more.
got the U,
Uh-huh.
and then you got another parentheses 3 infinity.
Thank you, thank you, thank you. There's the answer. Mathematics. Rather than saying it like this, which is true, no, we prefer this. Yes. Nice, and there's the answer. Now I gotta watch my time here. Letter F, probably the last one I'll be doing myself here. Here we go. Now, did we determine yesterday maybe a time for the break?
2.
Oh, 2 o'clock? Yes. Most students know that time for a break. They may not know how to use the quadratic formula, but if I say, what time is break? 2 o'clock, Professor. What's the quadratic formula? Oh, I don't know. I know that time for the break. Let's do one more here. I think we're starting to see what's involved here. Next one looks like this. My last one on the handout. Looks like this. And I was sort of debating whether or not to even place this on the handout, but I did. That's the last one I'll be doing. They want you to find all the numbers that will satisfy that inequality. I'm hoping I can apply sign analysis some way. Okay, guys? This is will be my last one. Any concerns? Anything at all that you can do there? How would you get started? This last one I will be doing. Anything at all? Goodness. All of a sudden you open up the quiz on Friday, you see that staring at you. How you gonna do it? Last one. Anyone? Go for it.
Should one side be 0?
Yeah, you gotta need that, thank you. She said it. She said one side, Professor, looks like one side always has to be 0. 0. Where else did I have 0? I need a 0 on one side. I've been placed not on the right hand side. So here I gotta be careful. If she wants that, which we do need, let's do this, guys. Take x plus 2 over x plus 3 and move over. You gotta move this over. I'm writing like this. Subtract. X subtract 1 over x subtract 2. And you get less than or equal to, you get the 0 that she wants. Gotta have the 0. She's exactly right. Now, another issue. Let's call this step 1. This one's going to be a little lengthy. Does anyone have an idea now, what on earth are you going to do with this mess? On that left-hand side. What do you think is calling for it? I'll give you a hint. Back in elementary school when everyone was smiling. Elementary school, my goodness, teachers were smiling, students were smiling. I used to be a supervisor of student teachers back in the day. I'd walk out to, you guys may have had a student teacher at some time in your life. My job was to walk out from the university and visit the school where the student teacher was placed and review and then give them suggestions on how to do something better maybe. So I watched my teachers and student teachers. Boy, everybody's smiling. Wow, I love this school. Everyone was smiling, teachers were smiling, students were smiling. I was so happy. I thought, this is a happy place. Yeah, I looked at their scores. Oh. I think a little bit too happy. scores were not that great. There's all those smiles on those faces. Now I need to see here, guys, what would you've done back then? You actually were doing this, and it looks much like this. What have you done here? Probably use
Made the denominators the same.
a common denominator, in this case of 4, from the elementary school. Now, what on earth is going to be my common denominator here? We're not in elementary any longer. I need to put these two together, like you did back then, with a common denominator. What is it?
X minus, no.
Now, go ahead, go
X
for it.
minus 6, I was gonna say.
Let me get it.
X minus 6, but I'm not gonna tell you.
Well, okay, I think you're trying to expand it out for me. Tell
Yeah.
me what it looks like in its raw form. What would you attempt to use for your common denominator? Back here in elementary school, it's 4. What is it here? Yes.
Would you times x plus 3 by x minus 2?
Nice. Nice. You gotta use that. We intend to put them together. I'm not gonna multiply that out. Now, you know what happens. Back in elementary school, you say, Professor, remind me of those happy times back then. There was a 4 there. And more than likely, your teacher showed you you need also a 4 here. And to get a 4 there, you probably back then, more than likely, you multiply the top and bottom by 2, the true guys, now everything's over 4. Well, I want everything over this, so I gotta do something here and make these match. What do I have to do here? To get this? Something's missing. What's missing? The x subtract 2. I gotta put it in, multiply the numerator, denominator by it, and I'll come back to it. Check out my second fraction like you would back in elementary school. I got x subtract 2, I want this. I need the x plus 3. Here. You talking about a mess? You gotta be careful of this one. You guys, let's see what we got here. Now, can anyone tell me, let's start cleaning this up a little bit. We got this is done. This multiplied out, can anyone tell me what x plus 2 times x minus 2 is going to give you? If you multiply the 2 together, what is that result here? I see a hand going up, yes?
X squared minus 4.
Absolutely. X squared subtract 4, which looks cute. I'm gonna block that off like that. Now, my next part, you gotta be careful. I think there's a subtraction sign here. I mean, extra careful. To get the next part. Well, the next part, I need to multiply these two together. And it's preceded by a minus sign. We're going to bring down that minus sign, so I won't forget it. Now, can anyone tell me at least, what do you think these two multiplied out would give me? X minus 1 times x plus 3 gives me, and I see a hand going up, yes?
X squared plus 3x minus, x squared minus 2x minus 3.
Oh, we're getting close. We're x squared plus 2x, I heard, and then what? Minus 3. Now you get one of these on Friday's quiz, oh. Now, step 3. I said, Professor, look, it's getting crazy on me here. Now you gotta clean this up. Let's go back to that numerator. We got x squared subtract 4. The next factor is preceded by the minus sign, so you're going to end up with almost like a distributive property. Distribute that negative. So we have negative x squared, subtract 2x. It's like plus 3, if I have no mistake. Still over this. Wow, what a workout. And this is still less than or equal to 0. Less than or equal to 0. That's looking better. Now, you guys who are watching me, make sure I do not make a mistake. I'm on top of the board up here. Collect like terms, well, not too bad. These two cancel. And it looks like if I cleaned up a little bit further, and I'll put the result down here, I see negative 2x minus 1 looks like in the numerator. Still over this. Guys, we'll squeeze this in, let's make sure you can see it. Jeez, what a problem. Oh, did I collect these terms correctly? Is that negative 2x minus 1? The true, guys? Still with that? Now, you're almost wiped out just from doing all that business. We haven't solved it yet. That's just simplifying. I said, Professor, that's the quiz right there. That probably would take me an hour. Let's do all that. We're not quite finished. Now, can anyone suggest to finish it up? After all that hard work, we can't miss it now. What would you apply now to find what numbers are going to satisfy this? Are we going to apply this again? Can I apply sign analysis? If I'm careful. Let's go to, on the side here, a number line. My two assistants, make sure you watch carefully, and do not let me make a mistake. Okay. Can anyone tell me? Or maybe I should tell you first, and you can tell me what I want to hear. When I go to the number line, I start placing my test numbers, not test numbers, critical numbers. My critical numbers, then I'll start testing. This one's going to have 3 critical numbers. This one's going to have 3 critical numbers. Can anyone give me, of the 3, any at all, and I'll place them on the number line, the way this looks? Anyone give me at least one of the 3? There's going to be 3 this time, not 2. Yes?
One of them would be -3 and 2.
Hang on, beautiful. He said, Professor, you better look at -3 down here. -3 would come from this one. And also a what? +2? You better consider those, because that would make a 0 denominator, and I've got to be careful with those. So let's go ahead and place those here. -3 and a +2. But definitely they got to be open. Because those two would force a 0 denominator. Here we go. Now the other one comes from the numerator. I see you hanging one up already. Be careful. What's my next critical number to be placed? Go for it.
1/2.
1/2. Let's see if it's 1/2. Be careful. I got -2x minus 1. If I go over on the side here and do this little business to try to find that next critical number, I move the 1 over, add 1, divide by 2, is it -1/2? Is it, guys? -1/2? And -1/2 is going to be in here somewhere. Oh, this is a beautiful problem to close this down. Now first, I always want my class to be with me on all this business. I want you to impress the Math 7 instructors, Math 8 instructors. Okay, now I'm ready. I have 2 of these open already. Why? Because these 2 would make a 0 denominator, and I can never have a 0 denominator. That's why they cannot be included. Can I include the -1/2? In other words, can I darken it in, if I didn't erase somewhere here, can I darken it in as I've done on a problem or 2 here? Can I darken the -1/2 in and say, Professor, you can use that? If so, give me the reason why. Or maybe it should also be open. What do you guys think? This right here. Should I also open it like these 2? Or can it, for some reason, be darkened? Or yes?
It can be done.
Okay, now she says, Professor.
It's less than or equal to.
Beautiful. That one can be included, and she's telling me, Professor, that right there saves us. Says it could be less than or equal to. So the one on top could work as a test number, a critical number. Guys, we agree with all that? Now let me get, before I start testing, if this had been missing, which it wasn't, back here, had been missing, now what would happen? With my critical numbers, would this one now be also open? If that equals mark had been missing, which it was not. Okay, now start testing. Oh, what a way to close this down. I got a test here, here, there, there. Good luck. Out to the left of -3, I'm gonna stay close by. I'm trying -5. In between -3 and -1/2, guys, do not mess up here. I'm gonna try maybe a -2. -2 falls between -3 and -1/2. Between -1/2 and 2, let's try maybe a 1. Out to the right of 2, we'll try a 10. And you guys have to show me your test numbers, because I give you partial credit when I give a quiz or an exam. You gotta show me your test numbers. Now, here we go, let's test them. -5. So, Professor, where are you going? I'm going here. I'm going to replace x by -5 and look at the sign. On top, numerator, -5, that's a positive 10. Subtract 1, that's a positive. In my denominator, -5 again. -5 plus 3, that's a -2. It's negative. -5 subtract 2, that's a -7. You gotta show me the signs. If I did it correct, I can think, guys, is that a positive altogether? If you look at it now, looking back, is that what I wanted? No, I did not want a positive. It says less than, I'm looking for a negative. So after all that effort, nothing. This would be so sad if after all this work, nothing works. Let's see what else. In between, I'm trying -2 here. -2. -2 times -2 is a positive 4. 4 subtract 1 gives me a positive. -2 plus 3, a positive. -2 and a -2 in this factor right here gives me a -4, a negative. What is all this together here? Is that a negative altogether? And that's what I'm looking for, so I've discovered by testing an interval that works. The next one I'm trying 1, who knows, it may work. Put a 1 in there, a -2 times 1, that's a -2. -2 subtract 1 gives me a -3. Looks like it's a negative on top, with that 1 placed in there. Down here, 1 plus 3 is 4, that's a positive. 1 subtract 3, my next factor is a negative. And please guys tell me what is all this together in terms of the sign?
Positive.
Positive, you've got a negative over a negative, which I do not want for this particular problem, can't use it. I'm trying 10. That's a -20, subtract 1 is a -21. 10 plus 3, that's a positive, positive 13. 10 subtract 2, positive 8. Altogether, is that a negative? That's what I wanted. So I discovered another interval that works. Now, since I'm gonna close this down, can anyone tell me the solution to this madness? Here's the original problem. What is the solution in interval notation? See a hand go up. Looks like this. How would you say it looks like in interval notation? Go for it.
Open parentheses. -3,
Uh-huh.
comma, -1/2
Beautiful.
with a bracket.
Look at that.
Union, open parentheses 2, comma, infinity, close parentheses.
Perfect. Perfect. Jeez. Inequalities. Now, maybe by show of hands, how many students actually have seen, I'm calling it sign analysis. Some professors will call it, use a sign table or something to know that. Let me see by show of hands, how many students have seen this method called sign analysis? I see a few hands going up. Powerful method. Takes a little effort though. Oh boy, does it take effort to go through all this and then determine what the answer looks like. Guys, you have the answer. By the way, if you get outside one of these intervals, this is not true. This statement will not be true if you get outside one of these intervals. Now, I know I'm finished, but just at random, in fact, I did. I first tried 10. 10 worked. If I get outside that interval, oh my goodness, something maybe that we tested maybe here did not work. It will not work. You gotta stay within that interval, or those two intervals that she gave me to make it work. Is that nice? Now, it's almost time for a break. So, Professor, where are you going with this? I thought we were going to practice a little bit. You are. Here's where I'm going. Now, I do want to take a break, a well-deserved break. I want to look at this. I want to sketch. This will set me up for after the break. Bear with me. I'd like to sketch this. Yes, beautiful. Let's say I want to sketch y is equal to x cubed subtract 4x squared. Bear with me, guys. Don't get too disappointed here. I'd like to know what that looks like. Just set me up for after the break. But I think it's nice to bring it in something we just did. I'd like to see what that graph looks like. Does anyone have an idea of what the graph looks like? My discussion after the break will just be graphs and functions, something called functions. Does anyone think they know what writing out x cubed subtract 4x squared might, look, you know what, hang on now, I'm gonna get even more interesting. Let's erase that square. Oh my goodness, yes. Let's consider that. Does anyone think they know what that looks like? Graph, is it a circle? Is it something called a parabola? Is it a straight line? What kind of a graph is it? And wait till you see how I'm gonna tie in this lesson here with this. Go for it. Let's do it again.
Yes.
Oh, he said, Professor, I think some type of curve. That maybe we have not done in this class yet. You're gonna set us up. Now, I see what you're gonna, Professor, before the break. You're gonna try to set us up here. Tell me before I get that curve. And he described it as an S curve. He says it's a curve, Professor. Professor, I don't think it's a parabola. I know what a parabola looks like. I don't think it's a circle. I definitely don't think it's going to be a straight line. But tell me, before we take a break, before I get to the curve, and see what it looks like, can you tell me what you might do to simplify this somewhat? Even before I jump into the details. Is there something you could do here to simplify this?
Factor,
Thank you. Factor out what?
at least, yeah, you can factor out x.
That's why I wanted x there. Let's take out x. You're so correct. If I take out an x, I got x cubed in the first term, you're gonna be left with x squared. If I take out the x common factor out of the second term, you'll be left with 4. Absolutely. Then, those of us who know we're factoring pretty well, say, wait, Professor, you're not quite finished. You can factor further. You want to tell me what the other part may look like, factored, make this more simple? We'll leave the x that was given to me. How about the x squared subtract 4? Will it factor further? In fact, it was called a difference of squares back then. What does it factor into? X subtract 2 times what? X plus 2. Y is equal to. Now there's the original rewritten. Look at this. Rewritten in factored form. Now, before the break comes up, can anyone tell me if I should apply sign analysis on this right now? With what you see. Can anyone tell me what are my critical numbers, there should be 3 of them, that I should place on a number line based on what we've already done? Does anyone see what the critical numbers would be from this?
0 to a negative.
Look at that. 0 to negative 2. The professor said each one of these factors equals 0, like we were doing over there. And now apply sign analysis, and we'll take a break here. Sign analysis. Here we go. Test here. Test here. Test here. We'll do our test fairly quickly. Test here. Now to the left, I'm going to try -4. In between, we'll try -1. Here we'll try 1. And out to the right here, I guess, oh, did I go -4? -1, oh yeah, 1. And out here, we're going to try maybe a 5. Wait here for the break. Guys, watch my work here. -4. You see, Professor, if you tie this in with the lesson here, you're supposed to go back and replace all these by -4 and tell me the sign. Well, if you replace x by -4, of course, it's negative. -4 subtract 2, that's -6. -4 plus 2, that's another negative. If I have no mistake, what is that product altogether? A negative times a negative times a negative is what? What is that? Is that a negative?
Yeah.
Yeah, wait, Professor, it's a little bit different than what we're doing now. See, it is negative. But it's not like these over here that you were now going to shade and show that's part of the solution. Can anyone tell me, before the break, in this particular graphing problem, sketching problem, what might that negative from sign analysis tell me about what's going on out here on my graph? You're going to be amazed. I'm short time in sign analysis, it's a little bit different, but what's that negative coming out tell me about the graph that I'm looking for out to the left of that -2?
Maybe where it is on the graph.
Thank you. Where is it then? If it comes out to be a negative, which is negative, it might be where? Might it be up here or might it be down here? Should it be above the x-axis, you think, if it's negative, or below? It's below. Now, you said, Professor, what do you mean? The graph probably looks something like this. I'm going to make a curve. So it's below. The sign analysis is being used here, graphing, which we're going to do after the break. In between these two, I'm trying -1. I've got to be careful. -1 put in. I see a negative. Oh my goodness, I'm squeezing all this in together. Gotta be careful here, guys. Testing here. Okay, -1. -1 subtract 2. Negative. -1 plus 2. Positive. If I've tested correctly. I did quick. Then I think all the others positive. What does that tell you about the graph caught between these two if it came out to be a positive? It's where? Above the x-axis. That means, wait, Professor, just extend this and show it's now above and comes down like that. Cute. Next, I'm trying 1. Let's try 1 here. Guys, I'm squeezing my numbers in here. Try it in blue here. Right here, 1. Replace x by 1, of course, positive. 1 subtract 2, negative. 1 plus 2, positive. I think altogether, is that negative right there? So that tells me by testing what's happening to my graph, my red graph, where should it be? Since they come out to be negative. Should it be below again? So it's going to drop below. How far below it drops, we don't know at this point. It's going to drop below, but it's got to come back. Pick up the 2. Woo! Now to the right, run 5. I've replaced x by 5 all the way across. I think to slow us down, or not to slow us down, just real quickly, I think they're all positive. Replacing all those x's by 5. Which is going to be a positive, which tells me out here to the right of 2, since it's coming up to be a positive, where's my graph located? Above the x-axis, so connect. There's the sketch of this. Using sign analysis. That's an application I had to show you before we take a break, in case we need it later on, not just for these problems, but even for graphing. Oh, is that what you had in mind when you said S, correct? Yes. You tell me it's going to look something like this to begin with. Now, if you don't think this is cute, you need to sit yourself down and say, that's something wrong with me. I don't think it's cute. This is cute. Who thinks you sign analysis and get a graph? And you certainly can do that. Okay, guys, looks like it's 5 till. We're supposed to do a break at 2 o'clock. Now, I know we're working hard. This will be we're going to be busy for 6 weeks. Now, 2 TAs. Anything you'd like to say before we take our well-deserved 15-minute break? Nothing to be said? Okay? My students, anything we said? My students are saying, no, Professor, we need a break. Okay, take your 15-minute break. You guys got